Welcome, this is TeacherBot. All systems are functioning normally. I'd like to look over some 249 questions, specifically the Module 3 work. All right, we're getting into sorting now. So when you go to zyBooks, you're going to see that we're going to be covering the most important things right now are selection sort and then bubble sort. So this video is going to cover m3t1, which is selection sort. Now what I want to point out is the code is provided. Now, of course, the code is provided in zyBooks, and so this is just copying that code from zyBooks. But what does the assignment say? Well, here we want to do one of the following. So I'm asking you to add some code. Now, I'm going to show you how to do the first one, how to add debug statements. You may wish to change those debug statements, but this will be a good start. It's up to you if you want to add in your own array of numbers, but notice that for a later assignment, being able to enter a user depicted array would be useful. So it may be good practice, but if you want, just follow along and you'll be fine. Now 3.2 is going to provide the pseudocode. That's the same for both books. This is the C++ version of selection sort. I'll do the Python version in the next video. Now the code's provided for you, and you're going to see here that an algorithm is provided for selection sort itself, which takes a int array, so think of that as a pointer to a list of numbers, an array of numbers of a certain size, and it will swap those values around to convert from an unsorted configuration to a sorted configuration. We need this function here, array to string, to print the values out, because there's not an easy way to take a block of memory, which is how we store the numbers in this case in C++. There's many ways you could do it, but this is as a block of contiguous memory. And so this code in Python is just a print statement. It's just print the list. Finally, we see the main is going to start up the program, and it's going to give us the input, the initial value, and the output values. Now let's look at a replit that I've been using. So if you would like, you're welcome to follow along. So I'm going to run this to confirm that it does the same thing as the zyBooks code, and it does. So now what we said here, well, let me do a few things. I'll just say this is m3t1 selection sort, which is of course is in csc249, and your name and the date, and I'd like you to put those values in. Okay. So this is, why did I add this? Well, I'll talk about that in a second. But in C++, this is known as a forward declaration. Now in C++, you can't call a function until it's been defined, or until it's been declared, rather. So a little bit later on in the class, next module probably, we'll look at using .h files and .cpp files so that we can properly organize our code and have libraries of code we've already written we can reuse. For now, a little quick shortcut is I'm declaring that this will be a function you could call so that selection sort can call it, because we're going to add some debug code here. And in fact, I've already added the code. I just commented it out, so we can add these lines in. But I want to do something here, and I want to say if debug, and I want to put this code like this. Okay. Now what you're going to see, of course, is if I try to compile this code, it's not going to compile. Right? So let's fix that. Well, first I'm going to confirm that. All right, it doesn't know what debug means. Why would I add this? Well, the idea is I want to have a lot of these print statements so we can follow what's going on. But in the actual code itself, switch const. True. Okay. Well, I want to easily be able to turn this code off because it's going to be very spammy. I'll actually show you what I mean. Let's run the code now, and you're going to see when I've added this code that it's showing as it steps through when it finds the smallest value. So here it's saying, oh, 2 is the smallest value at index 1. What is index 1? It's the second one, right? Because this is index 0. And it's finding the smallest area, because the way I think about selection sort, let's say you're playing cards. I used to play a lot of hearts. So you get your hand of cards, and then you put your aces, your 2s, 3s, 4s, 5s on the left side, and your king, queen, ace on the right hand side, so that you can know where your lowest and highest cards are. Intuitively, that's selection sort. You're just taking the smallest card at any one time, putting it to the left, and then repeat. And of course, once you've gotten the left hand sorted, you don't need to keep looking at it. So once the 2 in your hand is on the left, you can leave the 2 there, and then you're looking for what would go to the right of that. So it's finding it each time. But this is itself not enough to tell you, because first you find the smallest pass. In the pass, you find the smallest value. And then what you do is you swap the smallest value with the first value so that the first value is here. So I'm going to say if debug, and I'm just going to move this code into here. Okay. A little bit of tab, make it easier to see. Let's try it out now. So now it'll be a little clearer what's actually happening. Why would I add these \t's? For this reason, to make it easier to read. So first pass, you find the smallest value 2. So we swap it to here. So now it's 2, 10, 78, 4, and so forth. Then it finds the 4, and then it swaps the 4. So now you have 2, 4, and so on and so. Again, you can't really see what's going on here. So we're going to add one more piece of debug code to see it. Okay. Now this is where I'm calling this method that was already written for us array to string. So I say if debug. Put this right here. Okay. And I'll put this over here a little bit, make it easier to read. There we go. Okay. Now, hopefully, as you see all the parts fit together, you'll kind of see why I wanted to do this. Because in debugging, you're trying to trace through the steps. Think of yourself as you, the human, trying to run the code and see what would happen. So you could, for example, take these numbers by hand and just shuffle them around on index cards. So here we see 2 has been swapped. I swap 2 to the beginning, and so just like I said, 2 is first. Next pass, I find 4 is the smallest. Now it's got to go through all of these to find the smallest, right? So every time you see a smallest, it's reading the remaining of these. That's why this the sort is big O of n squared, because it takes n operations to read the whole list each time, and then you do that n times. So it's roughly n squared. So now that I've found these first 2, I have 2 and 4. And again, these highlighted items, you don't need to sort. They're already sorted. So I'm only looking at this part of the list from now on. Then we find 10. Oh, but 10 is actually not the smallest. 7 is the smallest. Okay, so that was the third pass, and now we've swapped that. So now I have 2, 4, and 7. And then I find 10. Now notice 10 is already in position 3, so it doesn't get moved. That's kind of interesting, that it checks for it. It doesn't have to do anything. We may come back to that later. I look for 11, so now it's 2, 4, 7, 10, 11. So you can kind of see how this process is happening. But again, let's say you were to use this in a piece of code. This is half a page of text that a user would just be bewildered by, because it doesn't mean anything to them. It only means something to us when we're trying to understand the functionality. Well, that's why I can go in and say false, assuming I can type. And voila, by turning off the debug statement, there you go. So, and if I wanted, I could have different levels of debugging, but I like to have a nice bool that says debug true or false. Now, so what that means is, when you compile the code, this code is compiled into the code, but since this is a constant, it never actually runs the code. So it's not really slowing it down. Even if you had a lot of code in here, it may make the program slightly larger, but it's not actually taking up any appreciable runtime. So one thing I'll do now is I'll turn it back on just to show you what it looks like when we take the other list I put in. Again, if you want to experiment, you might try using like a cn statement to read in your own numbers, but we'll look at that later. So here I have an example of the numbers being totally backwards. So you're going to find it's going to go through, and it's going to take a while to find the first one, right? Because the smallest number is at the end each time. So after one pass through, there's my smallest number. So now it's 1, and then 7, 6, 5, 4, 3, 2, 1, 2, 8. So now it finds 2. So now we have 1 and 2. And now it finds 3. So you have 1, 2, and 3. And at some point you find that it's entirely sorted. In this case, the fact that it's swapping these values has sort of accidentally caused it to be sorted. All right, that's this video. So hopefully that will explain it. Again, just to remind you, how do you get the code out? You can just download this one main.cpp, and that'll be sufficient to turn in for m3t1. The next videos will cover this version in Python, and then I'll cover bubble sort.